kind of loud. But as you can hear, the vocoder is having a problem there. And now I have a, and again, you need to experiment with different types of music. So I'm not saying music won't work or it will work. You've just got to try out some music and then you'll figure out one that will work okay. Here is some, I think it's a cello or a bassoon through an A-cal vocoder. But again, if you're going to play Bruce Springsteen or ZZ Top through it, it's going to go, might go wild. Or you might just turn down the volume. You have to experiment a little bit to find the right sound and different types of music. Okay, any questions so far? Okay. Why don't we, just to get some more basics out of the way here, equalizers. In digital, and I kind of want to take you back to Joe's voice. We have analyzed Joe's voice. We have all the aspects of Joe's voice digitized. So it's all zeros and ones now, not analog anymore. Zeros and ones are being transmitted through the air. So the phone has built in it an algorithm to work together with the equalizer. And these functions are both in the switch and the phone. In my chart here, you can see that there are, for the sake of simplicity, I just took two paths of RF energy traveling. If this is my cell site, there's energy, you know, transmitted all around. But let's just focus on these two paths. There is this path here, which is directly to the mobile, path number 2, and then there is path number 1, which reflects against a building. It's obvious that this path is shorter than this path. So at one point, zeros and one arrive here. So again, Joe has been digitized. His voice is all digital, zeros and ones. One stream of zeros and ones arrive here, and then another set of stream and zeros and ones arrive here a bit later. So let's say this is my mobile here. That's my mobile. The antenna is seeing one stream here, another one here. There is a delay between the two. If the delay is within a certain acceptable limit, the equalizer will kind of try to line it up and everything will be fine. But if the delay between Joe's voice samples is too wide, the call will drop. So here I am standing between these buildings. I can see the antenna, and I can't even make my phone to work. It happens very rare, but it happens. Okay? And what you want to do then is step aside and try the phone again, because then the reflective pattern changes. So whenever you receive calls like that or problems, you know, that's probably what's going on. The equalizer normally works okay, but you might have these very strange situations. All right? Now, any questions about equalizers? It's pretty straight. So there is two new elements that come into digital: vocoders and equalizers. All right? Yes?
Why's the call drop? Because, well, why doesn't it just grab?
Excuse me, why does the call drop? Why doesn't it just grab the early signal and hang on to it?
Well, that's the problem. It's receiving two signals. Let's say, for instance, let's say, you know, that the digitized samples coming out of the vocoder from Joe are like this, okay? And remember, this string here represents everything about Joe's voice. The depth of his voice, his articulation, his pitch, everything. Now the same set, let's say this is reflected signal number 1. Reflected signal number 2 is shifted in time, like this. So what happens is the system is seeing two conflicting signals, 0 and 1, you know, and it continues like this. And whenever it sees conflicting signals that it can't line up, things will go wrong. and then the call might drop as you're driving through that area, or you're trying to initiate a call and the phone won't work. And again, this happens very rare, but it happens. Yeah.
So does that mean that there's one area that you drive through every day, that area is a dead zone, and you drop the call every time you go through that area? Or does that change?
If you accidentally end up in the same spot, that same particular spot where that reflective pattern happens to be the way it is, then yes. That's a good question. But we won't have areas like that, okay? Again, this is a very, very rare scenario. But you see, the whole purpose of this class is to give you the raw truth, so to speak. Because you will have complaints from people. You will have people tell you, I cannot distinguish Mary from Jane. Yes.
So what you're saying is, in analog, what you've described as multipath distortion, analog will hold on to a signal, and it'll go whoosh. That's what that is.
You could compare it with that,
Yeah,
yes.
but digital, in very rare instances, just doesn't do multipath distortion.
That's right.
Okay,
Yes.
thanks.
Yeah, and also another aspect of digital, I'm glad you brought it up. If in analog you're used to a static sound, you know that staticky sound? In digital, let's say you enter areas with poor coverage, you're going to hear something different than staticky. It's kind of muty. If I may go back to Joe, his voice samples, Joe, his digitized voice samples travel. As Joe, let's say Joe is driving, he's talking, and the vocoder is analyzing his voice, sending all these voice samples. He enters a hole in our system. The vocoder receiving his samples on the other side, the cell side, is receiving conflicting information about Joe's voice. It might just entirely go wrong in terms of regenerating Joe's voice. So what do? We mute the signal, because what comes out of that, it doesn't sound very well. Let me let you listen to what it's going to sound like. We have an example of a digital call going through an area with holes. So this is, you have the static sound, so keep in mind what it would sound like staticky and analog. This is what it would sound like in digital. You see, it mutes. Because in that particular instance, when it's muting, you would hear something that is so horrible, and we just mute it. It would be a completely misrepresentation of my friend Joe.
Is it the same type of mute when two people are talking at the same time on digital?
No, this is different.
Because two people like duplex can't talk at the same time, is that true?
Oh no, two people can talk at the same time. You can talk at the same time.
It doesn't mute the other person out?
No. Oh no, because every conversation uses one time slot in a voice channel. For instance, let's say I have a voice channel, right? An analog voice channel, 30 kilohertz. In digital, we split this thing up in 3 time slots. One person would be on this end, and the other person would be on the other side. Oh yeah, can happen at the same time.
Because I had a conversation, and is it because there is a delay then?
Yeah, we want to record it too, you know.
There's a delay in your voice?
Well, there is a delay, but the delay is about 230 milliseconds, because there is a lot of processing going on, you know, analyzing of a voice and digitizing it.
So during that
But you don't,
there could be a mute if
no,
the conversation is
no.
too fast?
Conversation is not muted at all. There is a delay that you can't hear. 250 milliseconds is a delay that you cannot hear. If, for instance, I give him a cellular phone, and I have a cellular phone, and both him and I are engaged in a conversation, we're on digital here. If I can see his lips and he can see my lips, then yes, you might notice a slight delay, but we're banking on the fact that we don't see each other's lips when we're engaged in a conversation. But there is no muting of
So the
one
mute
way.
would only happen because of a poor signal? Or
Yes.
because of a weak area?
Only of a poor signal. We're not muting one way or the other way. No, no, not at all.
Thank you.
Any other questions?
digital, we're not going to hear the delay in the sound, and then we're not going to hear like we're in a tunnel. I tried the Nextel system, and
Yes.
there was a delay, and it sounded like I was in
Yes.
a hallway, and I heard everything.
Absolutely. The Nextel system is a modified GSM system, and it doesn't work that well. There are some problems. Our system works according to the IS-136 protocol, and I will be talking about the protocols right now. You will not hear any of those things that you're hearing in the Nextel system. Okay? Yes.
Nextel's brochure says it's TDMA.
Yes, it is digital. But you see, TDMA, digital, all means the same. TDMA stands for time division multiple access, meaning you can squeeze more voices in one voice channel. Now, in the Nextel system, they squeeze a lot more voices in one voice channel. In the GSM system, they squeeze about 8 voices in one voice channel, but that voice channel is very wide. Okay? And I will talk about this. There is different protocols, different ways of applying TDMA. Like ours is according to the IS-136 protocol. And the one before IS-136 was IS-54, the earlier version of digital. GSM is also a digital system. The Nextel system is also digital, but it is a different protocol. What is a protocol? A protocol is an agreement how the signals, the voice samples will be ordered. Okay, like in IS-136 TDMA, we agreed to use 3 time slots in one voice channel. In CDMA, we also digitize the voice, but then we mix it all in one big pot almost of voices, and each having a key. And then the phone filters out the right key, the system filters out the right key, and associates that with the right set of voice samples. And they just use one voice channel for everybody. Instead of us using 416 individual voice channels in CDMA, they use one big voice channel wide, 1.25 megahertz. And I'll show you some more on that, okay? Any other questions?
Yeah, what's the possibility of crosstalk in digital?
Of course, since it is an analog voice channel that we're using, and if we have some interference issues there, you will have issues like that as well, all right? So it's the same problems that we're having in analog, you would have them in digital as well. Obviously, you will have less of it because we're more sensitive now to ensure that, number one, we have the coverage so that nobody will experience any of that irritating muting. And number two, let's do our frequency planning right. Let's ensure that we're not overshooting antennas into areas causing interference and issues like that. But it's the same as what I was saying before. Any other questions? All right. Now, let's talk about these protocols for a quick sec here. The analog system that we have now, better referred to as AMPS, okay, uses a 30 kilohertz wide channel. IS-136 or IS-54 uses the same analog channel with 3 time slots in it.